As we start manipulating dynamic range in the post-production process, there's really two tasks we're going to try to complete. The first is to reduce the dynamic range, which is called compression, or we're trying to increase the dynamic range, which would be expansion. Now, if we think of reducing the dynamic range, there's two ways we could actually accomplish that. We could make the loud stuff quieter, or we could make the quiet stuff louder. Either way will decrease the dynamic range. We'll get a more consistent performance, or a more consistent recording. If we want to increase the dynamic range, we have two similar choices. We could either make the loud stuff louder or make the quiet stuff quieter. And that would increase the distance between the loud and the quiet. One of the most common things is actually to reduce the dynamic range or compress the dynamic range. And the first way we might want to accomplish this is that previous example I talked about, which was taking a vocal and trying to make all the words a little closer to each other in level. Now, there's a couple ways we can accomplish this. The first one would be to kind of chop up the vocal, isolate each individual section with editing, and increase the gain using some kind of clip gain feature in your DAW. And it can be a very good way to approach it because you're just changing kind of word by word. Another really common way to adjust the level of a vocal so that it's more consistent is what we call riding a vocal, or riding the fader, in which we play back the performance and we just move a fader up and down kind of opposite the dynamics of the performance. Actually, if you look at it really fine, what's really happening is we're kind of making a line that's drawing along the bottom side of the waveform in the DAW. In fact, you can even do that yourself after you finish a vocal performance, kind of zoom out, just take a pencil tool that's controlling volume, and just kind of draw a line right across the bottom of the waveform. And what you're really doing there is saying, okay, if the vocal gets loud, I'm bringing the level down. And as the vocal gets quiet, I bring the level back up. It's a real kind of simple procedure, but it is quite effective. And one issue with that you might want to think about is then you start doing this vocal riding on your main fader. So you look at the DAW, and that fader is going to be jittering up and down, which is fine, but that makes it kind of hard to mix later. Because what if you want to bring the whole vocal down in level? So this is one instance where you might want to examine kind of a gain or trim plugin in your DAW to give yourself another gain stage. So you'll have one insert that's the gain or trim plugin, which you can use to ride the vocal to even out those levels. And then you'll have the main fader so that you can mix the vocal and have it at a good level within the mix. Maybe even automate that for dynamic purposes or musical purposes over the course of the project. Now, that process of vocal riding is kind of algorithmic, you know? You're kind of just saying, okay, if the vocal gets louder, bring it down. Vocal gets quiet, bring it up. It seems like some kind of thing we could just train a computer to do. And that's in fact all that these dynamic processors are doing. There's just a rule. If the vocal gets too loud, bring it down. Or if the vocal gets too quiet, bring it up. And that's all these dynamic processors are. Our compressor, it's just a simple rule like that. And what we're doing really is the same thing a compressor does. We tell the compressor if the vocal gets above a specific set point, a specific threshold, start reducing the level, right? Kind of drawing along the bottom of that waveform. And then as the vocal or signal gets below that threshold, we bring the level back up, just what we were doing by drawing on the bottom of the waveform. So all these dynamic controls, all these dynamic processors, they are just changing volume. But they do it in an intelligent way. They do it by listening, by analyzing the signal itself, and then responding to it. These are all what we call nonlinear devices, in that they react differently at different amplitudes. Just like distortion is a nonlinear device, as it gets above a certain threshold, it starts reacting differently. Compressors, limiters, expanders, and gates are also nonlinear devices. And they're going to have a set of parameters. Things like threshold, attack, release, and ratio are going to be common among all these dynamic processors, but the rule will be different. Now I want to talk about the individual parameters we see, what they mean, and then the different rules on the different dynamic processors.